Assalamualaikum. I came with an interesting topic of A-level maths, that is about logarithm. This is my second detailed lecture with you, and you know that this is for paper 3 for A-level, that is for pure maths. So let's talk about log. In order to have a discussion about log, you must be familiar with the one of the most important concept, that was about indices. Maybe you people are familiar, and you must familiar with indices topic in order to find the answers or questions for log. You can check my channel to scroll down and find out the indices lecture that I recorded for IGCSE or GCSE. You can understand the indices, or you can recall the indices process through my that lecture. So let me check, either this is on recording. Yeah, this is. Okay, so let's start. You know that if you have 2 is equals to 2 raised to the power x is equals to 8. This question is due to indices. This question is indices, and you have to find the value of x. Find what is the value of this x. You can break down the 8 in the power of 2, and then after comparing the bases you can find it. No issue. So let's do it. 2 raised to the power x is equals to 2 raised to the power 3, because 2 times by 2 will make us 3. Bases are same, so on that comparison you can say your x is equals to 3. That is the answer. No issue. Okay, this is your answer. But if you have some situation in which you have to use log, for example 2 raised to the power x is equals to 11, or 2 raised to the power x is equals to 8, 2 raised to the power x is equals to 10, for example, this is impossible to solve, because there is no number through which you can take its power as let me choose as 11, because 2 raised to the power 5 make is 10. Okay, this is 11. Yeah, it's fine now. So 2 raised to the power x is equals to 11. There is no number whose power after taking the power of 2 will make is 11. Not possible. So not possible to solve. And the author demand to find the value of x. What I can do next? So in order to solve these types of problem, mathematician involve the concept of log, like through which you can solve it. Alright, so if you have the final form, for example, that is a raised to the power x is equals to b, that is a final, or you can say as a general form, and you have to find this x. This a and b are constants, and maybe algebraic expression depending upon the situation, but mostly a and b are seems to be constant. And you know that this x is variable, maybe 2, maybe 3, whatever it could be. So in this type of question you have to apply the log on both sides. Are you understanding what I'm saying? A raised to the power x is equals to b is the question in which you have to take care of log. So how you can apply the log? Its general form suggests that if you want to solve it by log, because you don't have another option, you have to make the power as it is, just like x, and the base of this x, that is a. A is the base now, x is the power, a is the base. So x will retain the first position, and this a is shifted on to the other side, but with a base of log a, and b is constant, so b remain as it is. This form is known as log form. This is your log form. Let's solve the question that I assign you or guide you over here. 2 raised to the power x is equals to 11. So it is 2 raised to the power x is equals to 11. You can solve this question. You can find the value of x as x retain its position as it is, and this 2 will make the base of 11 with a log. So log of 2, 11, just like that. Second question. Second question suggests that if you have 5 raised to the power 2x, which is equals to 8, so 2x will retain its position and 5 will be shifted over here with the log. So log base 5 and here is 8. In this way you can actually make the form of your question as log. I think so you understand what I want to say over here. Next concept in the questions you will see in the past paper, you have to deal with two types of questions. First one is making a log, and second one is reverse step. Means log form is given to you and you have to reverse as an indices form. This thing that you have to work from log form, you have to make a index form. How you can? Just like I told you in the upper part in the previous slide that it was 2 raised to the power x is equals to 11 and applying the log on both sides. So log of 2x which is equals to log of 11. So x will retain its position and 2 with log will be shifted onto the other side, and that will take a form log 2 11, just like that. Now I have to do the reverse form. This expression is given to you, this one. Let me highlight with another marker. This form is given to you and you have to go back to this form. This is the reverse step of logarithm. So let's find how we can. This is reversing step. So let's find the solution for one question, then you can understand how you can. For example, question number 1 suggests that log of 2x minus 3 which is equals to 4, and you have to find the value of x, but in the indices form, or you want to get rid of this log, you don't want to have a answer in form of log. Definitely reverse step would be applicable. What you can do next, you know that x minus 3 will retain its position and this 2 will shift it as a base of 4 with log, because I'm applying the anti-log process now. So this log will disappear and it could be written as only 2 raised to the power 4. Mostly students are basically mixing the steps. They are writing 4 raised to the power 2 just like that. That is totally wrong, because this is base. Log of 2 will also become the base of 4, so it could be written as 2 raised to the power 4. Don't mix the step, be sure to do the right step. This 2 will remain the base but onto the other side and making as 4 the power. So it gives me x minus 3 which is equals to 2 raised to the power 4 is 16 and x could be written as 19. So this is my final answer. X is equals to 19. I just did the reverse step and find the answer. There are some general or authentic results that you have to memorize in your mind. I'm writing over here. First one is log of log of any base may be 1, 2, 3, 4, whatever, and 1. I have to find log of 1 with any base. Its answer would be always 0. And second result is log of base is 10, power is 10. It's always equals to 1. These are two results that you will use over here in the next lessons or in the next questions. So be sure to note down these rules on your notebook or your copy. That would be helpful for you finding the answer for questions or for further discussion. All right. Next, the other point for the logarithm is basically for powered logarithm. Power log. If you have log of a and having some expression over here to the power n, for example x plus 2, you know that log have some properties, that is log of x plus y can be written as, this is x times by y, could be written as log of x plus log of y. If you don't know these properties initially, then you must have to look here. Log of x times by y could be written as log of x plus log of y. Let me rewrite, this is not too much clear. Log of x plus log of y. This is the first property. Second property is log of x minus log of y could be written as log of x dividing by y. And the third property is log of x raised to the power n could be written as n times log of x. These are the three properties of log that you have to work for. So this is the product rule of, or you can say power rule of logarithm. You will take advantage of the third property that I told you over here, this one. So this is log of a x plus 2 whole to the power n. N would be shifted over here at the start, and log of a times by x plus 2 would be remain as it is. This is the general form that you have to work for. Instead of x plus 2, there could be anything, maybe 3, maybe 4, maybe x square plus 2, maybe x4 plus 5 plus 3, maybe x cube plus 2x minus 3. It could be anything, no issue. But it should have that form, that is log of a x plus 2 whole to the power n. For example, let's solve a question. Log of 2 x raised to the power 7. It could be written as 7 log of 2x. Right? This is the answer. Means x could be anything, but that will be the use of that property that I guide you over here. Okay. So some students are confused, like they will do the wrong steps. Just a second.